Okay, welcome to lecture 28 of Python program. In the previous video, we had taken up a number of functions which are exclusively designed to work on lists. And there's one thing that I noticed the video got a bit lengthy because I was typing all the code and then demonstrating it. So, what I thought was, in the interest of time and trying to keep things concise and short, what I'll do is I'll first prepare the notebook like I've done it here, and then I'll execute the cells as I walk you through every programming cell in this notebook. So let's begin. So in this video, we'll focus on one very key aspect of lists in Python: list comprehension. What exactly is list comprehension? List comprehension refers to the creation of a list from a sequence of values. Now, this sequence can be a predefined data structure, or it could simply be generated from another loop. List comprehensions have been proven to be faster as compared to loops. List comprehensions are fairly concise in the sense that they help to reduce the number of lines of code that we have to write in order to implement a certain program. They are elegant in the sense that they help us to convey the idea in a limited number of lines of code, and they are also shorter in length. As a result, you would require less time to code. So, greater the number of instructions that you have to type, more would be the time required to code those instructions. So, if you're working with list comprehensions, then there's always this advantage that you're able to express ideas in fewer lines of code. As a result, you require lesser time to code the entire program. So that is a brief introduction on list comprehension. Now let's move ahead to the instructions. So let's look at a number of examples now. So first we'll look at the process of creating a list of values from a sequence. In this particular cell that I have now highlighted, I'm trying to create, or I'm trying to generate a list by using natural numbers from 1 to 100. So how do we go about it? Because we are trying to create a list. Remember, the objective of list comprehension is to create lists. The objective of list comprehension is always to create lists. Now, how we create the list, that depends on the program, or that depends on the problem that we are trying to solve. But at the end of the day, using list comprehensions, we will be creating a list. The output of list comprehension will always be a list. Now, if we look at this particular line of code, then we'll be able to understand how list comprehension works at a surface level. So you see, here we are making use of a for loop. This for loop is helping us to get numbers in the range 1 to 100. The range function, as it is defined here, takes a lower limit of 1. That means the numbers will start being generated from 1, and it will go up to 100. The upper limit, the range function, it starts from the lower limit, so it's inclusive of the lower limit, and it goes up to 1 less than the upper limit. So here the upper limit is 101, so 1 less than the upper limit would be 100. So the range function here would generate all natural numbers starting from 1 and going up to 100 in increments of 1. And every time a number is generated, that number gets stored in this variable item. So this part, this for statement, is helping us to get those natural numbers. And every time we are getting a natural number, we are appending it at the end of our list, which is called my underscore list. So whatever value we want to store in the list, that value has to come here. Generally, you will find list comprehensions will be accompanied by for loops like these. For statements are common when it comes to list comprehensions. So you will have this for statement which will be responsible for generating the values, and then what you have to the left of the for, so what you have here is item. This is the part which goes into the list. So whatever you have on the left hand side of the for statement is what is appended at the end of the list. So what do we have here on the left hand side of the for statement? We have the variable item. What is item taking? Item is taking values starting from 1 and going up to 100 in steps of 1, in increments of 1. So first item will contain a value of 1, and that 1 will be appended at the end of my list. Then item will contain a value of 2. 2 will be appended at the end of my list, and in this way it will go on till 100. So if I execute this particular cell, and then if I try to print out, this is an example of the slicing operation where we are trying to print out the first 10 values in our list called my underscore list. So if we execute this, as you see, the first 10 values have been printed. You could try a different range as well, perhaps from 10 to 20. And here you see the next 10 natural numbers starting from 11 have been printed out. And if you want to investigate the length of my underscore list, you can use the len function. So we get an output of 100, which means that 100 natural numbers have been successfully added to our list using list comprehension. So this is the first example of list comprehension. The next example involves not taking the loop variable directly and appending it at the end of the list. Instead, we are performing some operation on this loop variable. Again, in this example of list comprehension, you have a for statement. This is our for statement. The for statement once again is responsible for generating one number at a time, starting from 0 this time, because in the range we are passing just one value, meaning this is the upper limit and the lower limit by default is taken to be 0. So you start from 0 and you go up to 9 this time. Again, it's 1 minus the upper limit. Here only one value is specified in the range function, which means 10 is the upper limit. We'll go up to upper limit minus 1. That means we'll go up to 9. So 0 to 9. And every time a value is generated, that value gets stored in our variable I, which is the loop control variable. And what are we storing? What are we appending at the end of our list? We are squaring the value of I. So initially the value of I will be 0. The square of I will be 0. So you see the first value which gets appended at the end of the list is 0. Then I takes a value of 1. The square of 1 is 1 itself. So you have a 1 here. Then I takes a value of 2. The square of I is again 2 square. So that becomes 4. And in this way it goes on till you reach 9 and get 9 square equal to 81. Once again, whatever expression we have on the left hand side of the for statement will get appended as a list item to our list, which in this case is new underscore list. Let's try to execute this. Once we execute this, the execution is successful. When we print out the values, this is what we get. So that's the second example on list comprehensions. Now, list comprehensions are not used only with numbers. I don't want to give you any false impression by taking all examples involving numbers. So let's try to work with strings. Now, this is something that you would want to do in certain applications related to text processing, that you want to. So you have a corpus. Corpus essentially means you have a list of text values, and from this list of text values, from this corpus of text values, you want to filter out certain text and you want to discard others. So here what we want to do is, here we are working with all the strings. Our objective in this particular cell is to take every string and then convert it into uppercase. So all our strings which are stored in the list words are in lowercase. We want to take every string and convert it into uppercase. So what do we do here? Once again, we'll have to use list comprehensions. I mean, you can use for loops as well, but here we are focusing primarily on list comprehension. So here what we do is we go through every item of our list. Our list is called words. And when we have this for statement, what we are doing is we are picking up one string at a time from the list words. And every time a word is picked up from the list words, that word is converted to uppercase using the upper function, which is built in Python. In the previous two examples, we were generating numbers using the for loop. Here, we are extracting strings. We are extracting inputs from a predefined list. So this words list, this has already been defined for us. We are iterating over each of the items in this particular list words, and what we are doing is we are performing some processing on that item. And what processing are we doing? We are simply converting the string to uppercase. As simple as that. And we are appending it at the end of our list called uppercase underscore words. So don't think that you'll always be generating numbers from a for loop. You could also have an existing sequence. You could also have an existing list like we have here. And you could extract one item at a time from that list, perform some pre-processing, and create a new list. So here what we are doing is we are going through an existing list called words, which contains various strings in lowercase. We are extracting every string and we are converting it into uppercase and forming a new list consisting of all words in uppercase only. I hope that makes sense. So if we execute this, as you see, we get back we do not get back any output. The control moves to the next cell, and when we execute that, we get back all the strings in uppercase. Moving ahead, we can also create a list of tuples. So don't be under the impression that you will only have lists generating another list. Of course, you will have lists involved. The output, like I said right at the outset, the output of list comprehension will always be a list. But you could also add the flexibility of having another data structure. Like here, we are trying to create a list of tuples. And we are making use of a function called enumerate. What enumerate does is, it takes a list. Here, we are applying the enumerate function on a list called words. So this words object that you see here, this is same as this list. This particular list, which we had defined earlier called words, this same list is used in this enumerate function. So what the enumerate function does is, it takes every item from this list called words and it appends the index value of that item and returns it as a tuple. So what will happen here is, if you look at this for statement, what is the first item present in the words list? In the words list, the first item is the string hello. And what is the index of hello? We know list indexing, positive indexing starts from 0. So here, the first positive index of the list words is 0. And 0 corresponds to the string hello. So what enumerate does is, it takes this string hello, it stores it in the variable name, it takes the index of hello, which is 0, and stores it in the variable I. So when you apply the enumerate on a sequence, you get back a tuple. That's why we are capturing the value. We are capturing the value in two variables. Can you see? In the for statement, now we have two variables, I, name. I is capturing the index of the item and name is capturing the item itself. And we are preparing a tuple as shown by the pair of parentheses enclosing I and name, and we are appending it at the end of the list called word ranking. In this way, so when I execute this, I do not get any errors, and when I print word underscore ranking, I get back a list of tuples where every tuple has an index value associated with the value of the string. Now, the next point that we would like to talk about is the execution time of list comprehensions. While introducing list comprehensions to all of you, I had mentioned that list comprehensions are faster. Let's try to establish that using an example. Here we are making use of the time module. The time module has a built-in function called time, and we'll be timing this particular statement. This is the statement that we are working with. We are simply trying to create a very large list. So if you look at this number, I think there are how many zeros here? 1, 2, 3, 4. 1, 2, 3, 4. So 8 zeros and a 1. So that's 9 digit. That's a huge list that we are trying to create, a huge list of natural numbers. And we are trying to time this operation. How do you time it? You simply record the start time and then you record the end time. And what happens is you put the state excuse me, you put the statement in between, and whatever is the difference between the two times that you have recorded, that gives you the duration of the instruction execution. So if I execute this, as you can see from by looking at this star, it means that the cell is still executing. Now you get back this number 12, that means the execution is over. Now if I execute this cell, so the difference between the start time and end time comes out to be close to 6 seconds. So it took around 6 seconds to execute this particular instruction. So we recorded the time at the beginning of the instruction execution and we recorded the time at the end of the instruction execution. And the difference gave us the duration for which the instruction was executed. Now, if we try to repeat the same operation, if we try to create a list of natural numbers, a list of these many natural numbers using a for loop and time our operation, let's see what happens. If I execute this, as you can see by looking at the star, it's still executing. Again, we have mentioned the start time and we have mentioned the end time. And in between the start time and end time, we have our instructions. The instructions that we want to find the duration for. And if we print the difference, we see that it's roughly 13 seconds. Close to 13 seconds. So you find when you're using list comprehension to create a list, your time duration is close to 6 seconds. When you're creating the same list using for loops, the time duration is close to 13 seconds. That means you're achieving a 2x performance enhancement when you're using list comprehensions. So list comprehensions help to speed things up. Now you could also have list comprehensions based upon conditions. So far we have been generating values either using a for loop or from an existing sequence, and we have been appending those values at the end of the list. Either we are appending the values directly like we saw while we were creating natural numbers, or we are performing some operation on the item. For example, we are taking the uppercase equivalent of a string, or we are squaring the value that is being generated from the for loop, and we are appending it at the end of the list. But we have not applied any condition. The question is, can we apply any condition on our items? And based on the condition, we can add it to the list. So kind of filtering operation, is it possible? The answer is yes. We can apply conditions on the items before appending them to a list. For example, in this particular cell, we are trying to build a list of odd numbers in the range 1 to 25. That means if we run a loop, if we run this particular loop, the one that I have highlighted, then we'll get all values in the range 0 to 24. I think I need to make one change here. So it should be, so it says in the range 1 to 25. So I should have 1 comma 25 plus 1 because it's exclusive of the upper range. Now this particular for statement will give me values starting from 1 and going up to 25. But will I be taking all the values and appending it to my new list called my list 3? No, I'll only be appending the odd numbers. So how do I keep a check? I keep a check by having a condition after the for statement. So far we have seen the for statement, the one that I'm highlighting, and for statements similar to this, and we have a value on the left hand side of the for statement. The value on the left hand side of the for statement is the value that we are trying to append at the end of the list, and whatever we have on the right hand side of the for statement is the condition that we are applying before appending the value. So what is the condition that we are applying here? Is the number that is being generated from the for, is it an odd number? If it is an odd number, if on dividing the number by 2 we get a remainder of 1, then we are appending it as it is at the end of my list 3. Now if we execute this, we see that we get a list of odd numbers between 1 to 25. So this is how you can apply a condition on the item before appending it to the list. Another example could be, you have a list of strings again, and you want to extract only the even length strings and append them to a new list. So what do? Again, same thing. You iterate over every string present in your input list. Here the input list is my list of strings. So what we are doing is we are iterating over every item, every string in this list, and we are checking its length. So if the length of the string, if the length of the word that has been taken from the input list, if the length happens to be an even value, that means if I divide the length by 2 and get a remainder of 0, which we can achieve using this mod operator, the percentage operator, if it comes out to be 0, if the length on dividing by 2 gives a remainder of 0, that means it's an even length string. And if it is an even length string, what we are doing is we are taking that string and appending it to the list, our target list, which is even length strings, as it is. We are appending the list item from the input list, my list of strings, and appending it to the target list, which is even length strings, as it is, provided it's an even length string. So again, this is another form of filtering that we can apply on a given input list based on some condition. So if we execute this and if we print out the values, you see here in this output we have only those strings which are even length. Moving ahead, we could also have multiple conditions on our list comprehension operation. For example, we want to extract, so we have defined a list called my list of strings. This is a list that we had used earlier as well. I'm simply printing it out so that you can recollect. Now what we want to do is we want to extract the even length strings which start with the letter F. So there are two conditions. The first condition is the string has to contain even number of letters, and the second condition is it must start with the letter small f. When you have multiple conditions, what you do is, again, you go to the right hand side of the for statement. So this is the for statement that we have in our list comprehension. You go to the right hand side of the for statement and you write your conditions. So here in this given problem, we have to include two conditions. The first condition is it should start with small f. Of course, the order does not matter. You could also have the length condition to be the first condition. That won't make a difference. You have to simply mention both the conditions. Now, both the conditions have to be satisfied in order for the item to be filtered out and put in the target list, which in this case is my list 4. Here the target list is my list 4. And if an item has to go into my list 4, it must satisfy both the conditions. Excuse me. It must satisfy both the conditions. So we are including the conditions one after the other. So if it starts with small f and if the length is even, then we are taking the string value which is stored in item and appending it to our target list, my list 4, as it is. And if we execute this and then print it out, we get back two strings, friend and flower. Both these strings start with the letter F and contain even number of characters. And the last topic, the last coding topic that we want to discuss is nesting of list comprehensions. So you could also have a list comprehension within another list comprehension. This is slightly a bit more tricky to understand, but I'll try my best to give you the illustration. Firstly, we are defining a matrix. That means we are defining a list of lists. Here it's a list of lists which you can interpret as a matrix. The other way of creating a matrix would be using NumPy. Anyway, we are not getting into NumPy now. For now, just keep in mind we are creating a matrix using a list of lists. And after this matrix has been defined, we are applying the list comprehension operation to create a target list called flattened list. What we want to do is we want to take this matrix, which is two-dimensional, and we simply want to flatten it. That means we want to convert it into a 1D vector. We want to convert it to a vector. 1D vector, I don't think it makes sense. Vectors are one-dimensional. We want to convert it into a vector. That means we want to take all the elements of this matrix and simply append these elements one after the other in a target list in a row major order. So we'll go row by row. The first row is 1, 2, 3. So we'll extract one element at a time. We'll extract 1, append it to the list. Then extract 2, append it to the list. 3, append it to the list. Done. First row is done. Now go to the second row. Extract the first element, append it to the list. Second element, append it to the list. Third element, append it to the list. And in this way it will go on. This is what you mean by the flattening operation. What we are doing is we are having two loop statements now because it's a nesting of list comprehension. And as you have seen through so many examples, list comprehension would involve a for statement. So we are having one for statement for the row part and another for statement for the inner list part. So what will happen is first this for statement will be taken. So for num in row, so try to understand this. Let me try to explain this once again. Let me rephrase what I said. So first you have this outer loop. So for row and matrix, so what row will do is it will extract the first inner list 1, 2, 3, and row now, this variable row now contains this inner list 1, 2, 3. Now using this variable num, we will iterate over row one element at a time. So num will first contain 1, and see, we are having num on the left hand side of our for statements. So num gets appended to flattened underscore list. Then what happens? Num takes the next element of row, which is 2, appends it to the target list, flattened list. Then num takes 3, appends it to the target list, which is flattened list. Now num is done iterating over all the elements of this inner list. Now what will happen? Now you will go back to the outer loop. The outer loop is this particular loop which I have highlighted, which is based on the loop control variable row. Now row will take the next inner list, which is 4, 5, 6. Now what num will do is it will iterate over every item in row. Row, mind you, now contains 4, 5, 6, this second inner list. Row now corresponds to this second inner list 4, 5, 6. Num will first pick up 4, append it to the target list, then it will pick up 5, append it to the target list, then 6, append it to the target list. Then again you will go back to the outer loop, which is based on row. Now row will pick up the final inner list, which is 7, 8, 9, and the inner loop, which is based on num, it will pick up one element at a time from row. So it will first pick up 7, append it to the end of the list, 8, append it to the end of the list, 9, append it to the end of the list. Now you have no more inner lists to work with, so your list comprehension will come to an end. So if I execute this, print the matrix, and then print the flattened list, you find that you have a single list containing all the 9 values. So this is how you can apply list comprehension, nested list comprehension. And you can understand that the major drawback of list comprehension is that it's a bit difficult to understand, and finding errors can be a bit tricky, especially when you're using something like nested list comprehension. So, this is a trade off that you have to make, whether you want to increase the efficiency of your code or whether you want to increase the readability. So, a lot depends on the target audience for which you're writing the code. As a result, you have to make this decision yourself. So with that, I would bring this video to a close. Thank you for watching. If you found this video useful, do give it a thumbs up, comment if you have any doubts, and do subscribe to our channel. And I'll see you in the next one. Bye bye.